All right, so I want to take a look at these problems that I assigned over break, and I want to make sure that I have solutions for all classes working on this. So question number 1 says we want to calculate the force between two charges, Q1 and Q2, separated by 5 centimeters. There's a little bit of unit conversion to do here, so let's be clear on one thing. 2 microcoulombs, for number 1, remember 2 microcoulombs, that means 2 times 10 to the negative 6th coulomb. And we'll do the same for Q2 for 4.0 microcoulombs. That's going to actually be 4.0 times 10 to the negative 6th coulomb. And for the centimeter separation, 5 centimeters, let's just be clear, we need to convert that to meters. And the way that works is we'll take this 5 and we'll move it over 2 decimal places to 0.05 meters. So then what we're going to do is we're going to end up plugging that into Coulomb's law, which is simply F equals K Q1 Q2 over the distance squared. And again, let's just be clear, this is Q1, this is Q2, and this is going to be the distance. So we just plug those numbers into this formula here, and when we actually do that, we'll end up getting an approximately 29 Newton force. Okay, that's for A. Now, one of the things is when we talk about charge separation and what happens when things are doubled or halved, I actually do not want to do part B with numbers at all. What I want to do is I want to compare. So it says let's double the separation. So let's do this formula, K, Q1, Q2, and I'll plug in R for D, R squared. That's our original formula. Now what we're going to do is let's actually double the separation. So what's going to happen is I'm going to take K, Q1, Q2. Now be really careful. When you double the distance, the whole distance needs to be doubled. So that's going to be 2 times R. And when we actually work this out, that's going to be K, Q1, Q2 over 2 squared is 4 R squared. That's the new F. So I'm going to call this F old. And I'm going to call this F new. And what we're going to get is that F new is going to be 1/4 of F old when we compare. And I do that by looking at the expressions. If you want to be really obnoxious, you can actually divide everything and cancel, but that seems a bit much. Now, here, if we double both Q1 and R by a similar process, they work it out in the answer key, and I'm sorry, I should write this better. This is B1. So for 2, little I, that's going to be K, 2Q1, Q2 over 2R quantity squared. And when we actually work that out, what we're going to end up getting is F new is only half of F old. And I'm going to leave it to you to actually show that F new actually equals F old in number 3. Now, for number 2, we want to calculate the net force on the middle charge. And then we've got, so 2, 3, and 4 are some interesting questions. And I'm going to actually just take a look at those. Like this. All right, so let's actually take a look at question 2. All right, so here's the problem. We have 3 charges placed on a line. And we're going to calculate the net force on the middle charge. Let's be really careful. First, let's look at force directions. We're looking at charge -2 microcoulombs. We know that the 3 microcoulomb charge pulls it this way because of attraction, and we know the 4 microcoulomb charge pulls it the other way. So what I'm going to do when I set up this formula is I'm not going to worry about negative and positive. I'm going to worry about which way the forces actually pull the charge. By writing this arrow and this arrow, I've already taken care of the sign. So I'm going to get the net force as K 4 microcoulombs times 2 microcoulombs over 4 centimeters squared. And I'm going to put a negative sign out here to indicate that the force goes to the left. And then here I'm going to add to it K, 3 microcoulombs, 2 microcoulombs over 4 centimeters squared. Sorry, over 2 centimeters squared. And I'm going to make this a plus sign to indicate that the force goes to the right. Now, we'll do a version of this with vectors, just to be a little bit clearer today. So now let me actually translate things into the unit system that we use both in IB and in AP Physics. So we have -9 times 10 to the 9th times 4 times 10 to the -6th, 2 times 10 to the -6th, over 0.04 squared plus 9 times 10 to the 9th, 3 times 10 to the -6th, 2 times 10 to the -6th, all over 0.02 squared. And when we actually add all of this up, we're going to end up getting, I believe, 135 minus 90. And so we'll end up getting here 90 newtons. Sorry, 35 minus 45, which gives us 90 newtons worth of force. So that's how that's going to work for number 2. And I think I'll do one more problem on this particular set here. We'll take, oh, I like this. Whoops. It says in the previous question we want to determine the position of the middle charge so that it's in equilibrium, and that will actually work. So I'll actually do number 3. This is number 2. I think I'll do number 3 on the same page. I'll just zoom out just a little bit. So for number 3, here's what we're going to say. We want to know the force so that this charge is in equilibrium, meaning that there's no net force on it. So here's what that means. We have a total distance of 6 centimeters. So for number 3, it's a little bit of a different situation. I'm going to call this Q1, Q2, and Q3. This distance I'm going to actually call X, and this distance here is going to be 6 centimeters minus X. I get the 6 from the fact that 4 plus 2 is a total of 6. Okay. So I'm going to get this answer in centimeters just because it's a little bit easier. And now I'm going to set up the force equation like this. The net force should be 0, and this is going to be negative k 4 microcoulombs times the unknown all over x squared plus k 3 microcoulombs times the unknown. Oh, sorry, it is a known charge. Let me replace that. This is going to be 2 times 10 to the negative 6th, and this will be 2 times 10 to the negative 6th. And that's going to be 6 minus x squared. Now here's what's going to happen next. There are some things that cancel because this equals 0. I can cancel out k. I can cancel out this charge here. So I end up getting an equation that looks like this. I'm going to get 4 over x squared, 4 over x squared equals 3 over 6 minus x quantity squared. And we can actually simplify this. We can get a quadratic equation if we want, but we'll end up getting that x is about 3.22 centimeters when we solve. Okay, I did want to go ahead and set that up. So I am leaving out a few details because I want you to try to work that out and do that algebra on your own. That's a big part of both IB and AP. So that is an important thing to be able to tackle. These are the first 3 problems, and I'll put these online now.